Hello and welcome to Thursday's edition of Cracking the Cryptic. And let's start today's edition by noting that Cracking the Cryptic seems to get into the most unlikely places. This, believe it or not, is a photo of one of our biggest and most generous supporters, Peg, with a handmade CTC scarf in Antarctica. It beggars belief, but that really is in Antarctica. Isn't that incredible? So we have finally got to the very bottom of the globe, and it's proof that even from this little old attic in Surrey, things can be achieved, it seems. Now, what have we got for you in Sudoku land today? Well, we have got the latest puzzle in the extraordinary series of the Sudoku professor, Richard Stolk. Now, for those of you who don't know, Richard has been doing this series for, it must be the best part of a decade now, in which most weeks he publishes a brand new Sudoku on Logic Masters Germany. And these Sudokus have all had different rules. And he is on number 349. That is 349 Sudokus in a row, each of which has a different rule set, and all of which, if you go to Richard's page on Logic Masters Germany, they're all rated absolutely top tier. So not only is Richard sort of coming up with new things, but he then makes an absolutely brilliant puzzle based off the new thing he's invented. I mean, it beggars belief, frankly. It really does. It's such an extraordinary achievement. And this one's been recommended a few times. Apparently this one's basically got a perfect rating and only 2 stars out of 5 for difficulty. Now, I will say that on Logic Masters Germany, some of the ratings, they are a bit perplexing. Sometimes you can try a 2-star puzzle and it takes you 2 hours to do it. And sometimes you can try a 4-star puzzle and it might take you 10 minutes. But in general, these ratings are a guide, so hopefully this one will be actually approachable. We'll see in a moment. I'll read you the rules in just a second. There's one more thing I wanted to mention. Over the last week, I have been having an awful lot of fun solving just the most extraordinary Sudoku stroke puzzle hunt ever. I mean, it is unbelievably good. And I'm absolutely thrilled to tell you that last night I finally finished it, and it is magnificent, and this means that it's definitely good to go, and we're going to be releasing this as a Christmas gift to those of you who supported us on Patreon. Thank you so much, everyone who does that. We do try and ensure, and we do ensure, that it's the best Sudoku club on earth. And this is going to be our way of saying thank you to you. So it'll probably come out in about a week's time. And just, hold on to your hats, because it is going to blow your minds. Anyway, I'll tell you more about that in the coming days. Let's get on with X Distance Sudoku, for that is what it's called, by Richard Stolk. And the rules are as follows. Normal Sudoku rules apply. Digits outside the grid have to be placed in the corresponding row or column in the given order. Where the second digit is placed X cells away from the first digit, and X is the digit in the first cell of that row or column. Right, I read that out too quickly for my brain to actually interpret what it was saying. Let me think about this for a second. Digits outside the grid have to be placed in the corresponding row in the given order. Okay, so let's have a look at this column, where the second digit is placed. Oh, I see. So I've got to put the 3 above the 1 in this column. Let's just put some in. Let's put the 3 and the 1 there and there. Where the second digit is placed X cells, that's 1, 2, 3, 4 cells. So we put a 4 in here. Is that what we're saying? I think that is what we're saying. So that's how we have to fill the grid. Let's have a look at a row clue. 8 and 2 here. So if we put the 8 here and the 2 here, 1, 2, 3, 4, 5, 6. That's saying that square is a 6, I think. Good grief. How on earth are you meant to do this? Anyway, that is our task in this corner of the internet where we rely on things like rationality and logic. It is a very tiny corner, but it nonetheless does exist. Do have a go at the puzzle. The way to play is to click the link under the video as usual. Now I get to play. Let's get cracking. And how on earth do we get cracking here? Let me have a look. We have got 3 8s in this set of clues. What does that mean? Oh, right. No, I see. I do see something anyway. I can write 2 digits into the grid because thinking about 8s has made me think about high numbers. And high numbers are tricky numbers, aren't they? Where are we going to put high numbers in this column? And in particular, where are we going to put the 9 in this column? Because something I can tell you is that a Sudoku only has 9 columns. So if I was to put a 9 here, that would be telling us that the 8 and the 2 have to be 9 columns apart. Well, if I put the 8 there, 1, 2, 3, 4, 5, 6, 7, whoopsie, we'd have to put the 2 in column 11, which won't work. So, yeah, I think this is the only place the 9 can go. So we avoid having to apply these rules to anything, or any of these actual clues, and similarly that must be a 9 in row 1, so we can avoid applying the 9 to any of these clues. So at least we have a small beginning. And probably what we have to do now is to think about, the digit I originally thought about, which is 8. Because wherever we put 8, we're basically defining the perimeters of that. So if this is an 8, we're now saying that the 2 is 8 away. So the 2 would have to go there, I think. 1, 2, 3, 4, 5, 6, 7. Yes, I know I shouldn't need to count that, but for some reason, it's a bit like when I'm playing Bubba Is You and I want to check that the water does kill Bubba. I still do it. Yes, sorry. So, okay. 8. So 8 in this column is in one of 3 positions by force, and whichever of these is the real 8, let's actually highlight those. Whichever of these is the real 8, it's going to plonk a 2 or a 6 into one of those 3 cells. And look, we've got a 2 or a 6 at the top of column 9. So is that useful? So if this was 8, 2 and we had a 2 here. No, actually, I think I'm not thinking about that very clearly. Yes, it's absolutely true to say that whichever one of these is an 8, it's going to force one of these 3 digits, but it doesn't force 2 of them. So I don't think I can use that domino at the top of column 9, although no doubt the comments will tell me why I'm wrong about that. What about 8 in row 1 then? Yes, yeah, that's a good question. Where does the 8 go in row 1? Well, we need to put an 8 in, and wherever we put the 8, it must use itself, if you like, within its equation. So it's going to have to be here in order for us to be able to fit 2 clues in that are sufficiently far apart. So 8 away from this one, 1, 2, 3, 4, 5, 6, 7, 8 works. If we were to try and do it here, the 7 would drop off the bottom of the grid. So this is the 8, and now we've got an 8 here, which has to be some distance away from a 4. But I don't think we know very much. Well, I suppose we know the 4 is in one of 5 positions. Is that a sensible thing to think about? Probably not. Let me just think about that for a moment. Is there some magic that means that we know which of these is a 4? I don't think there is. It feels more like to me that we're going to now have to think about 7 in this row. Or can we do anything else? I don't really like the look. I mean, I can see that's not a 7 because you couldn't put a 2 above it. If that's a 7... Yeah, 7 is very restricted, because if you do put 7 there, you do force the 2, 6 into exactly those positions, but that actually looks quite plausible. Okay, sorry, I'm now stuck. I'm not doing this with very much aplomb. Increase your aplomb quota, Simon. Yeah, how do we... we need more Cyrano de Bergerac here, more panache, and less whiffle waffling about. The 4 down here, is that doing anything? That's impacting this clue. Oh, yeah, okay, that's interesting. Yes, okay, one of those two has to be a 1, because the 1 must be to the right of the 4. Ah, and I can do that, because if the 1 was here, that would be 1 away from the 4, and I'd have to put 1 in there as well. That doesn't work. So actually, we get another digit. That's got to be the 1, and another 2 digits, because that's 2 away from the 4. So we get this digit as well. And all of a sudden, we have more things we can think about. Oh, yes, yes. What about row 8 now? Because I've got to put a 1 to the right of the 5. And the 1 can't go in any of those 3 squares. So the 1 has to go in one of those cells. Yeah, this is restricted though, because that square can't be a 1, because obviously the 5 has to be to the left of it in the columns. So that means that this actual cell cannot be a 1 or a 2. So that is at least a 3. And if it's at least a 3, this is really beautiful. It's telling us that the 5 and the 1 are in different boxes of the Sudoku, because they differ by at least 3 columns. And given that the 1 has to be over, well, it does actually have to be over there now, doesn't it? Originally, it had to be in one of those 5 cells as a result of this one, but now I'm saying it cannot share a box with the 5, which is to the left of it. So the 1 must actually be in one of those cells, and the 5 must be in one of those cells. Which means there's a 1 up there, I suppose, by Sudoku. It also means this can't be a gigantic digit, because even if I put... Yeah, I mean, it can't actually be higher than 5, I don't think. If that was a 6, the nearest I could put the 5 would be here, and then obviously the 1 is going to appear in box 9, which is impossible. So this is 3, 4, or 5. If it's 5, the 1 goes here. Is there anything wrong with that? I don't know. If it's 4, that's quite interesting. The 1 still goes here. Because if it's 4, I've got to keep the 5 4 apart from the 1, and the only 2 cells that works for are those 2. But if it's 3, the 5 could go here and the 1 could go here. Oh, hang on. Wasn't the 1 always in this position, or have I just imagined that? If it's a 5 here, you get a 1 here. If it's a 4 here, you get a 1 here. And if it's a 3 here, you still get a 1 here. That's very, very cool. That is always a 1. But bizarrely, we know nothing about the composition of these digits, because everything is still working. 3 forces 5, 3. 5, 1, sorry, 5, 1. 4 forces 5, 1. And 5 just forces 5, 1. And that 1, 6 is the wrong way round for this 1 to be useful. So, have we actually made any progress at all as a result of all of these shenanigans? The answer is, I fear not. Oh no. Oh no. What do we do now then? Have we learned anything more about... Have we learned anything more about anything, frankly? I feel like I'm really running out of ideas. I thought it was all going to be about high digits. I want to use this 4-8 clue because having this 8 in the grid makes me feel like we ought to be able to do something with it. 8 comes down here, 4 comes down here. If we put, I don't know. I really don't actually. That, I mean, even that can be a 4. If that's a 4, that would be a 1, and that seems eminently reasonable. Oh, that can't be a 4 now, because if that's a 4, that square actually has to be a 2, and it's going to clash down there. If this is a 4, can we get rid of that? Oh, yes we can, actually. That's beautiful. If that's a 4, that's 4 away from that, and that would have to be another 4 in the row. So actually I'm doing quite well here. 4 is here. If 4 is there, 1, 2, 3, 4, 5. Oh, this is right. This is ridiculously clever. Oh, good grief! Right, that's not 4, because if that's a 4, what's this square? Well, it's got to be 5, and now this clue is broken because we need to put the 3 on top of the 5 in this column, and it can't go there. Now all we've got to do now is get rid of 4 from here, and we know the 4 will be here in row 1. And if that's, yeah, okay, very simple. If that's a 4, that's definitely not 4 away. 1, 2, 3, 4, 5, 6. It's 6 away. So that cannot be a 4. That's really clever. That is really clever setting. So that is a 4, and that is a 1 as a result. And now that's not a 1. Which means what? I'm tempted to look at this clue now, actually, because I can see the 1's getting pushed over to the side. Is it this, or is it going to be something to do with the 7 in this row? Let me just think about the 7 in this row first. 7 in this row, I know it can't go here because it would need to have a 2 on top of it. If this is a 7, no, this is not a 7 anymore, because that would go 2, and this would have to be a Schrödinger cell. It would have to be a 1 and a 6 simultaneously. That won't work. 7 here forces 1, 6. That might work. I can't see why that doesn't work. 7 here forces 3. Oh, that doesn't work. 7 here forces 3 here and 1 here, which clashes. So that's not 7 either. So can we get rid of 7 here? That would be 4 here, 9 here. No. Bobbins. So I think the 7 in this row is in one of those two positions. I'm just going to highlight them like that in the hope that I remember there's some sort of restriction applying to them. Oh, the other thing I might think about doing, you know, is when I've actually done a clue, maybe I should mark it off so that I don't keep looking at it, because I keep looking at these clues over and over again. I'm going to do that. That one's done. This one is done. That one is not done. That one's no. Okay, so we've ticked some of them off. And now we have to think again, don't we? So how... Oh yeah, I was going to think about this clue. Because none of these can be a 1. Yeah, well, I think we have a similar thing to what we noticed down here. Once this square is at least a 3, and it now is at least a 3 because there's a 1 and a 2 in the column, the 1 and the 7 have to be in different boxes. Now, given the 1 can't be in that box at all, the 1 must be in this box. In fact, it must therefore be in this domino by Sudoku. And the 7, which is at least 3 away, is in one of those 3 cells. And unfortunately, I think all bets are possible there, aren't they? So, Okay, but the furthest away the 7 can be is 5. So this square is a 3, 4, or a 5. And that means... Oh, I know what it means. I know something it means. It might mean more things. This column is interesting now. But one thing it means is that that square is no longer a 7. Because if that's a 7... we had to go 1, 6, and the 1 now, this is so beautifully constructed. The 1 now has to be in this domino in box 2, so it can never be here anymore. So that cannot be 7, which means that's 7, which means that's 4, and that's 9. And that means one of these cells is 4, which, well, it's not that one for sure. So if one of these is 4, and what else does it mean? No, that 9 is not doing enough work. It means that that's not a 4 anymore. Oh, right, this is gorgeous. Yes, it is gorgeous. I don't know which way up this goes, but the 3, 5 pair in this column now, because they're one apart from each other, and this is one of them, it's either here and here. It's either those two or it's those two. So that square's got to be a 4, which means that square's a 5 to make sure this is the right distance away. Let me just think about this. So now, if it's these two, then we've always got to make sure the 3 is on top of the 5. So the 3 must be in one of those two squares. You can't put the 3 here, or this would have to be a 5 and everything would be upside down. And we don't want a topsy-turvy world. Okay, so what does that mean? The 5 is in one of those two cells. Oh, I know one thing it does mean. Those two squares have got to be enormous digits now, by which I mean difficult digits. Because whichever one of however this domino of 3, 5 is made up in two of these 3 squares, those squares now cannot be 1, 2, 3, 4, or 5. So these squares have to be selected from 6, 7, and 8. And that means... how easy is that to do? The answer to that is, unfortunately... So well, this can't be 8. We know that for sure, because 8 always references itself. So wherever we get an 8 in this column, it's got to be in a cell where we're putting an 8 into the leftmost digit of the row. So this is 6 or 7. Now if it's 7, you have to go 5 here. Oh, this is deliberate. This is so deliberate. This clue is so deliberate. Look, I've got a 5, 9 pair here. That's just basically saying that this square cannot be a 7 because this needs to be a 5. So that means that square is a 6. The 5 must go here. The 9 must go here. This square here is now not 6. So this is 7 or 8. Oh, right. And here's another little point of beauty. Whatever this is, that square is a 6. Because if this is an 8... that's got to be the 6 because it's got to be 8 columns away. If it's a 7, the 8 and the 6 have to be separated by 7, so that would be the 8, but the 6 will still be here. So that's always a 6. No, it doesn't tell us. Does it tell us anything about the 2? I don't think it does. Yeah, right, 5. 5 is now up here. So this is a 3, 5 pair. Once this is a 3, 5 pair, this tells us the order. So that's 3, that's 5. This is 7 or 8. This is telling us that the 8 and the 2 are 3 apart. So they're in different boxes, but only by 1 box. I have a horrible feeling, again, I can do something with that, but I can't see immediately how to do it. What about this square then? Oh, this is the same as this one. Oh, right, that's a 2. This is so clever, this puzzle, honestly. Look at this. If it's 8, the 2 goes here. If it's 7, you've got to go 8, 2, and the 2 still goes here. Now, this identical logic on these 2 squares forces a 6-2 pair here, which now means they're 3 apart. So that means that's a 3 out of absolutely nowhere. That is so beautiful. Now, how do I use that though? So in this row, I've got to place 2, 5, and 6 into those 3 squares. And have we got a way of doing that that's going to be useful? We have, if, I don't know. The short answer is I don't know. That can't be a 6 because the 1 must be higher than the 6 in this column. So this is 2 or 5. This one, if it's a 6 here, the 1 would have to be in box 7. It would have to be here. So 3, 4, 5, 6. This would have, if this is a 6, this has to be a 3, which doesn't work. Oh yeah, this is what we should look at. Yes, this is going to be tricky, isn't it? Because the 3 has to be at least, the earliest it can appear in this column is there. And a 3 here. 1, 1, 2. Oh, that can't be 5. Sorry, I've just noticed that can't be 5 because I've got a 5 in the column. So it helps if you do Sudoku occasionally, Simon. Sorry, so a 3 here. 1, 2, 3, 4, 5. No, and the 6 would drop off the end of the grid. So that's just never 6. That's the point, I think. 6 means you're 2 boxes away. And given the 3 cannot be in that string of digits, that's impossible. So this is 2, this is 5, this is 6. Now the 3 can't go here because that would force the 1 there. Yeah, this is gorgeous. Now the 3 can't go here because the 1 needs to move down. So the only place the 3 can go is exactly here, forcing this to be a 1. Those squares are now 6, 8, and 9. That's obviously not 9. Whoops. And one of these 2 is an 8. One of these 2, yes, whichever one of these is a 7 has an 8 next to it, and therefore this square is a 6. Now I've got an 8, 9 pair here. So this column is probably where we look now. We need 4s, 6s, and 7s. So this is 4 or 7. Oh, you can see in the column that's forced to be the 4. This is a 6, 7 pair. The 6, 7 pair now sees that square. That's got to be the 8. That means that's the 6. This is the 7. That's the 8 as a result of this clue. Actually, I need to tick off my clues. Let's tick off the clues. And all of a sudden, all the clues are getting ticked. Well, not all of them, but some of them are. 5 here. I've not even thought about this. 1, 2, 3, 4. Yeah, this clue's forced. We can do it now. That's got to be the 1. That's got to be the 7. That seems to suggest this is the 4 now by Sudoku. That's a 4 by Sudoku. This column needs 8 and 5. Yes, 5 here. That's a 5. This is an 8. That square's a right in. That's a 3. These 2 squares are a 1, 2 pair. Wow. Okay, and did we get this one done? No. This one needs to have 3 different. So, oh, but if that was an 8, 1, 2, this would be a 3. That's possibly possible. Yeah, oh, no, hang on. No, if that's an 8, that's a 2, isn't it? I'm getting confused with doing my 3 here and my 2 here. If this is an 8, this is a 2, which is not possible because of the 2 here. 8, 2, broken. That's a 9. That's an 8. So the 2 is in a different box to the 8. That means the 2 is in one of those squares, the 8 is in one of these 2 squares. And it's going to be exactly a sort of whole shoot away from wherever the 2 ends up. And, oh, 5 here for the 1 and the 6. That looks difficult. Yes, okay, this has got to be the 1. And this 1, 2, 3, 4, 5. The 6 must be at the bottom. That fixes the 6 and the 7. Good lord. Now we've got 3, 5, and 8 along the bottom. So this is a 3 or a 5. Those are 3s, 5s, and 8s. This clue is not done. This clue is done. That clue is done. This clue is done. That clue is done. Oh, that one isn't. That one isn't. Right, so there we go. We now know, I think, where we need to be looking. Yeah, hang on, 6. That means the 2's got to be really early. It's got to be here. So that's got to be 2, and then we've got to go 6 away for the 7. So 1, 2, 3, 4, 5, 6. That's got to be the 7. 7 is in one of those 2 squares. Those 2 squares now... Oh, now we know where the 8 goes. I see, sorry. Doing this with the least aplomb, but never mind. We are getting there, I think. 9 goes here. 1 goes here. These 2 squares have got to be 6 and 7, and we don't know the order, apparently. But we can now cross this clue off. These 2 squares are 2 and... Oopsie, 2 and 3. We can't... Oh, maybe this clue was going to help us. Yeah, how can that ever be a 2? The 7 would need to be 4 cells above it. It can't be. That's 3, that's 2. So that's not 3 at the bottom of the grid. If this was 7, the 2 would be here, which would be beautiful because it would resolve the 1-2 pair. If the 7 is lower than that, the 7 could only be here. 2, 3. Oh, hang on. 1. Hang on. Where else could it be? The 2... That won't work. It doesn't. The count doesn't work. If you put the 2 here, 1, 2, 3, 4 puts you on top. So that is the 7. That is the 6. That is the 2. That's the 2. That's the 1. That's a 1 by Sudoku. And I'm not sure, but it feels like we might be on the home stretch here. We've done that. We've done all the clues. Yeah, it's a Sudoku now. We are back in the world of Sudoku, having visited the world of X distances for a little while, and very nice it was there too. So that square is a 5 or a 9, this square is a 3 or a 5, which means the 9 in this column could have been placed by Sudoku some time ago. 9 goes here by Sudoku, 9 goes here by Sudoku, and I think all the 9s are done, are they? Yes, even the ones outside the grid are done. 3, 5 and 6 into... yeah, where does 6 go in this row? It can only go here. So these are 3s, 5s and 7s to place. And we can see that's not 3 and that's not 5. Let's have a look at this row. We need 3s, 4s and 7s. Oh dear. This was not a profitable way to look, was it? Let's have a look at the central column where we also need 3. That's a 7. There we go. Which means that's a 7, that's a 5, that's a 3. That square's got to be a something. 5. This square's not a 3. Okay, so those squares there have got to be 6 and 8, which we can do. That fills in the 3, the 5, the 8 at the bottom. The 3 and the 4 go in. This column needs a 4. It must go here. This needs to be 2s, 5s and 7s. The 5 goes here. The 7 goes here. The 2, 2, and that should be a 3. And I think we've solved the puzzle. And that was so clever, wasn't it? I mean, there were about 6 moments in that puzzle where you just think, wow, the logic is so precise and interesting. Let's just click tick. It says yes. The only reason I'm hesitant there, though, is that this grid has been created to be an 11 by 11 grid. So Sven, our programmer, seems to have worked some magic and somehow worked out that this is a 9 by 9 in the middle. But probably when I'm editing it, I will just have to check that this grid looks correct in terms of, you know, each box contains the digits 1, 2, 3, 4, 5, 6, 7, 8, and 9, and each row and column do as well. because I'm not sure whether the software check will work properly. But just a brilliant puzzle. What more can you say? I hope you enjoyed it. Let me know in the comments. I do enjoy reading them, especially when they're kind. And we'll be back later with another edition of Cracking the Cryptic.